Hello students, I am Tanmay. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we will discuss a very short but important or interesting topic, that is the conversion of internal alkyne into terminal alkyne. I repeat, keep it in mind, internal to the terminal, not the opposite one. Okay. So this thing we will discuss based on two examples. The first example is taken from a book. The second example is completely hypothetical, made by me. So this second example I will explain first, then we will go to the real. It will be helpful for you. Okay. So actually what are going to convert? See, what do we mean by internal alkene? Means the triple bond is in between the alkyl group. And what is terminal alkyne? Terminal alkyne means one part should be CH, and this is SP-CH bond. Okay, so this is the part. But see, here no SP-CH is there. This is SP-CC bond. Okay, so for that reason, what reagent we are going to use? We are going to use a reagent name as KAPA. What is the full name? Potassium 1,3-diaminopropane. Actually, better to say, this is for potassium, this is for amino, this is for propyl, and this is for amide. Then there is potassium 1,3-diaminopropyl amide. Okay, so from the name you can see this is actually a salt. Salt means this is the amine and its corresponding potassium salt, means if you react this with potassium, it will result potassium bracketed 1 equivalent. Okay, so it will result this NH minus with K plus. Analogous reagent you have also read KNH2, potassium amide in a liquid ammonia. Ammonia is a gas, that's why liquid. Similarly, this reagent is used in this amine, diamine. Okay, so keep it in mind, this is important thing first. So we have discussed about the reagent. So in reagent part you should write kappa and NH2. Okay, so this is the reaction, this is the reagent. Changing on substrate to substrate, reaction condition varies, but keep it in mind, these are very highly reactive reagent. That's why generally mild condition is enough to carry out the reaction. Okay, fine. This is the first step, and this the second step is hydrolysis, means H3O plus. Then the ultimate product we can obtain. Fine. Now, so this is the thing. Now discuss about the mechanism of this process, because mechanism is the most important thing, and during the mechanism you will understand why internal to terminal conversion possible, not the vice versa. So let's start the mechanistic description. As you can see, this kappa, as I told, so for better understanding now we will draw kappa in this way. Why I have taken symmetrical? Because in order to avoid confusion. So this is the NH minus and this NH2. Here the corresponding potassium. Now see, this is a amide, is a very strong base. That's why it is capable to abstract this allylic type. In double bond case it is called allylic, but let's consider this is a allylic type. Okay, so what it does, it abstracts this hydrogen. So what it result? This result CH3, CH minus, then C triple bond C, CH2 CH3. When this proton is abstracted, what is the thing? Now potassium is here. This is a carbon ion and this is the amine. So let's write it. NH2. So this is the also NH2. Fine. Now see, it has a resonance. Resonance means CH3 C. Actually, this is an allylic, so allylic double bonds are in resonance with the double bond is in conjugation, means it will come into open. So this is, sorry, it should not be CH. I have made mistake. This should not be H. Fine. Sorry, no, there should be H. Okay, fine. CH. Now double bond with C and double bond C minus with CH2 CH3. Okay, so this is and this is open now. So this is the thing. Now another carbon ion is generated. Okay, from one to another. So what happens in next case? So if you see that this is an allylic type system. So what happens next? This carbon ion abstracts the proton from this 1,3 diamine. How? Just let's draw everything as it is. So this is the NH2, this is the NH, 1H. So what happens? This carbon ion, right now as you can see that this. So what is the product in this case? In this case product is Allene. CH3, CH, double bond C, double bond CH, CH2, CH3. In this case, you please keep it in mind, right now this is sp hybridized. Both this and this means ultimately this and this both are sp2 hybridized. Previously it was sp3 hybridized when it was CH2 sp3, but right now after this sp2. Fine. This. So this is the Allene derivative form. Now what happens? See, there are excess amount of base. So base, what base can do? Base can abstract this proton. This. How? Let me clean this part. Okay, let's draw it here. So this is the N minus NH. 1, 2, 3. NH2. So similarly, it can abstract and result in preparation of a carbon. So the carbon ion looks like CH3, C minus, double bond C, double bond CH, C2H5. Okay. Now this carbon ion can undergo rearrangement, means this carbon come here and it can come here. So the resonance or canonical form is CH3, C triple bond C, C previously H, right now a negative charge, C2H5. So this is the resonance canonical structure. So now what happens? So now as you can see that this is negative charge right now. So this can also abstract proton from KAPA like that. So this is NH2. Because after proton abstract, this amine was generated. So this carbon ion will abstract one proton from the amine. So this negative charge will come on nitrogen. So what is the product? Product is CH3, C triple bond C, CH2, C2H5. Now please focus on this CH2. Okay, where this carbon this carbon is now CH2. So see, sp carbon now converted into a sp3 because of this. Actually, you can shift, is a shift of bond, rearrangement of bond. So this is now question how this thing will happen. So similar process like the previous one, using the same mechanism, this bond will be shifted. So I am not going to explain in details about the shift, but let me give you an idea. So similarly, instead of this there is a proton, so it will be abstracted. So here I am not showing everything. This is the carbon ion generation, then C triple bond C, CH2, C2H5, fine. Then what will happen? Undergo resonance, these, and this will abstract a proton from this NH kappa. So sorry, this 1,3 diaminopropane. So what it will result? It will result CH2, CH, means first resonance, second proton abstraction. I should better to show this. This is minus. This is CH2, C2H5. Then this minus will abstract proton from here and ultimately result in the formation of that protonated species, means CH2 double bond C, double bond CH, single bond CH2, C2H5. Fine. Similarly, this will be abstracted. So again another step. What will be the product? CH, C. Sorry. Let me draw it here. So next step, what will be the product? This is H, C triple bond C. So this will be converted into CH2. Now this is the CH2. Let me mark, and C2H5. I am just marking arbitrarily, no radio level. Don't be confused. Fine. Now the thing is that you can see from this internal position, this double bond is transferred to the terminal one. And this is the most crucial step, because in presence of this potassium amine, means KAPA, as a base, this proton is abstracted. We know actually this KAPA is N minus. I am not writing the spin. So it will irreversibly abstract this and ultimately result in C minus, C, CH2, CH2, C2H5. Now question why? Please carefully focus on this part. Question is why. Now you can see that this is a sp carbon. We know that among sp, sp2, sp3, sp has the highest acidity. So this is happened. And another thing, all these steps I have written are reversible. But this step is irreversible. And this is the reason for the propagation of this process and ultimately stops. So why I have given this H3O plus? Because this part, this carbon ion in presence of H3O plus, converts into corresponding terminal alkyne. CH2, CH2, C2H5. Now one question comes. Can't we stop the reaction at this stage? Means at this stage. This we have obtained during the reaction. So is it possible to stop the reaction? They say no, it is not possible. Reaction will continue because this bond, this is an acid-base reaction. This and base, kappa as an acid-base reaction very fast. So it will end up here. And reaction mixture, it will remain as a salt. So why this can't go back? Because it's a stable. Why you want thing to be go unstable? So this is the thing. Now there is one interesting point you must know. So means a simple question, if any triple bond is given, internal triple bond, will it convert it into terminal? Generally yes. Why generally? Because see, for this case example, let's take CH3, CH2. It's a hypothetical example to give you the knowledge I am giving. CH3. So previously, see this substrate and this is different. This is not symmetrical. So here there is a chance that the triple bond can propagate in this side or triple bond can propagate in this side. Both are possible. But here only triple bond can propagate at this side because Keep it in mind, any branching will stop the propagation of triple bond. Okay, keep it in mind. By mistake I told it also. Because why? Because first thing it will generate carbanion. Fine, means what I am saying, this will result CH2, CH2, C triple bond C. This is CH3, this is CH3, this is the carbanion. Fine, it will generate. It will undergo resonance to do this, means this, and it will result in CH2, C minus, double bond C, CH3. Fine. This canonical form will abstract a proton, that is also fine. This is proton abstraction. Then, in order to alkyne propagate this, see here hydrogen was needed, right now methyl. So this reaction cannot proceed in this. And as I told, the reaction is reversible. So instantly reaction will follow the other path, means this and this. So first preference will follow if some amount of reactant reacts and produce carbanion at this position, that also will come back and ultimately result in the formation of what alkyne? This alkyne. HC means I am talking about after workup, the final product we are going to get. So this C, CH2, CH2, 2, CH, this is methyl, this is methyl. So this will be our end product. So please keep it in mind for unsymmetrical how this thing will proceed. Fine. Okay, this. So we have discussed the basic part, now we will discuss the example. Okay, now focus on the example. See, this is the terminal alkyne, this is also, what is the difference? The carbon number. This is a 7 plus 2 C9 material. This is 1, 2, 3, 4 C5 carbon. So we have to increase, need 4 carbon. Another thing. See, there is a terminal hydroxyl. We have to keep it in mind. So let's do the discussion. How to increase the carbon numbers? C5 to C9. Let's add C4 in it. How? So we know that KNH2, this potassium amide in liquid ammonia generates the carbanion, means this is C minus. I am doing this fast. K plus. So this CH2, 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 OH. Fine. This is, now see, this is a nucleophile, carbon based nucleophile. So what can do? It can attack an electrophile. Electrophile means, for example, let's take, it's a straight chain thing. So C4 bromide or chloride, whatever. So this, so right now this is nucleophilic, this is electrophilic. So we can think that via SN2 process. So it attacks and it leaves. So ultimately what it result? This is a 4 carbon, 1, 2, 3, 4. Now along with that 4th carbon thing, there is one CC. This, and here 3 carbon, 1, 2, 3 OH. So this we found. So we have made the internal alkyne part. Now target is to how to convert this into this. Okay? Okay. So before conversion, it is essential to create block this. Why? Because if we don't block it, it may participate some other reactions. Okay? So, and another thing, it will destroy one equivalent of base, which we don't want, because this KAPA base is a very strong base, costly thing. So it is better to protect. How? Dihydropyran. This is famous for protection of alcohol. So what it does, so I'm just writing in this way. After protection, it resulted in, this is carbon, this is triple bond, this is oxygen with this. So actually you can think, so it must be in presence of a acid. Okay, so better to say pyridinium tosylate. This pyridinium OTS. So it's actually as this NH is acting as an acid to activate this, because what happens, this double bond first react with acid. Okay, I'll show you. This dihydropyran in presence of acid, what it produces, this double bond is protonated. How? See, this is in conjugation, so it pushes and it attacks. So ultimately it results in this this oxygen plus. So actually another canonical form is that oxygen positive charge is here, like this thing. So this indicates that this carbon, this center is electrophilic, electron deficient. Consequently, what happens, this alcohol attacks here and open. So you can think about, it's a protonated carbonyl type of thing, very activated. So this attacks and opens up and ultimately result in this type of moiety. Okay, so this is the mechanism to prepare this group. Fine. Now let's do the conversion. Now, as we have learned sometime before, if we put kappa and amine, corresponding amine, amine, first and second step. Second step, if we put H3O plus. Okay, so what will happen? That this migration will come this side and ultimately result this. Not only actually via C minus C CH2 7 OH K plus. So okay, I should remove the H3O plus, and second in presence of aqueous acid means H2 plus, it will work out. So how to think such problem? These are very big problem. I suggest you generally not to write this many things. What you can do? Just in order to save your time, you can write that this is CH2 thrice OH, here CH2 thrice CH3. So in this way you can save your time, and sometime during this stick writing we end up with some mistakes. So it is better to write in this way. I have written such that you don't face any problem for understanding. So this is the thing. Now question, why reverse could not be done? Means I am saying that internal to terminal. Why not terminal? Because if you keep the same condition, this is highly stable. So this is stable. So why it undergo rearrangement there? It will not go. That is the reason that reverse thing is not possible. Okay. So please keep this thing in mind. So this is the end of this discussion. If you like these videos, if you like this video, you can help me to grow my channel. First of all, please subscribe my channel Chemistry and Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. Secondly, share this video among your friends so that many people could be benefited from my effort, and I'll be very happy. And thirdly, please like the video, make some good comment. It will be a very satisfactory thing for me. So thank you again. See you in my next video.